Hey everybody, so we're going to be talking about how to use reasoning in geometry. So pretty much we've talked about these properties of equalities, and those are the ones that we took the notes over, right? And that's what we use typically algebraically. Now, in geometry, we like to prove why we're doing the things that we're doing. We need backup, we need evidence, right? And notice our properties of congruence here. They're actually very similarly named to the ones that we have right here. So for example, reflexive, symmetric, and transitive. These are all the same name. Now, the transitive property, of course, it's a little bit different when you apply it to, for example, segments or angles. So let's talk about the reflexive property, right? You'll remember with the reflexive property, it's just saying, it's kind of like looking in the mirror and you see yourself back. It's you. Nothing's changing. All right, and then so if we have segment AB, then it would be congruent to segment AB. Or, in the case of an angle, say you have angle A is congruent to angle A. And you're like, well, Miss Samji, it's the same thing. Yeah, but you're gonna need it, and you'll see why. It's especially helpful when you have 3 letters for your angles. It's super helpful. Now your next one, symmetric, remember it's almost like it's flipping across. So if you are told that segment AB is congruent to segment CD, then you can come in and write, okay, well then I can use, by the symmetric property, that segment CD is congruent to segment AB. The same thing can be the case for when you're working with angles. So for example, if they told you that angle A is congruent to angle B, well, fine, I can say that angle B is congruent to angle A. It's using the knowledge and the items that have been given to you and using it for you. Manipulate it in a way so that it works for you. All right, so transitive, this is based off of the law of syllogism. Remember, if A, then B, if B, then C, then, therefore, A, then C. So they would give you something like this in terms of segments. AB is congruent to segment CD. CD is congruent to segment EF. Whoop. Therefore, you can draw the conclusion that segment AB is congruent to segment EF. Now, sometimes you might find the second statement right here, you might prove it and then end up having both of these. You might not be given both of them, but you might find them during your proof, and you can use that to use the transitive property if you need it. All right, so let's try with angles. We've got angle A is congruent to angle B, and we have found that angle B is congruent to angle C. So then you can therefore use that angle A is congruent to angle C. All right, so we're going to be using this for 2-column proofs. Now, we did talk about 2-column proofs a little bit last time. You got exposed to them. Now what we're going to do is we're going to try to solve it. This is just an algebraic proof. So the question we are being asked is, what is the value of x? So we have to solve for x, and we have to justify each step. Why did you do what you did? Well, first thing we have to notice is in order to solve for x, we've got 2 angles that use it. Now, both of these are also a linear pair, so you can use that. You can also use the angle addition postulate to say that both of these add up to be 180. There are a lot of things. So we're going to say 2x plus 30, and you can put these parentheses or not in this case. It's good practice, but you don't need them. And I would say, hey, my reason for this is I'm going to use the angle addition postulate. All right. Now, and typically you wouldn't show this part in your steps where it's all you did right here was combine like terms. You wouldn't typically show this in a 2-column because it's not really a reasoning. You're just simplifying it for your sake. Because what you're really needing to do is you're trying to solve for x, and what you're doing is you want to get rid of this 30 here, and you want to get rid of it from the opposite side as well. And when we're subtracting, what we're using is the subtraction property. So now we have 3x equals 150. So we subtracted that 30 from both in order to get to here. Now, in order to continue solving for x, we're going to have to divide both sides by 3. All right, well, because we are dividing, that is the division property. And when you're doing algebraic stuff, it's kind of easy because you're like, well, it's just the property that I just did, or the operation. And what you would end up getting is x equals 50. Yay! You just did an algebraic proof. Now comes your 2-column proofs, all right? So this is using what all we've learned in that first chapter about angles, lines, all those fun things, and all the definitions that I kept making you write. They're back. So our example says to write a 2-column proof. They've given us that angle 1 and angle 3 are vertical angles, and we have to prove that angle 1 is congruent to angle 3. Well, here is what we need to set up first. It's a 2-column proof. So let's set up our 2 columns. All right, you've got your statements. And your reasons. So your statements are, well, what's happening? What is your work? Right there. And your reasons is, why did we do that? Why were you allowed to do that? What did you use? Your first step for this is always going to be to write your given here. Whatever your given is, that's what you're going to start with. And if you have multiple, you'll write them down. You'll write them all down. And I'm going to shorten this so we have more room. So angle 1 and angle 3 are vertical angles. That was given to us. Now we need to prove that angle 1 is congruent to angle 3. So somewhere down here, we are going to prove that angle 1 is congruent to angle 3. Now the reasoning behind that, we're going to find that as we keep working. All right, so let's start with what we know. Angle 1 and angle 3 are vertical angles. All right. So what we can say is, ooh, you know what we can do? Look at that. That's a linear pair, and that's a linear pair. So I'm going to say that angle 1 and angle 2 are a linear pair. Angle 2 and angle 3 are also a linear pair. And if you want a shortcut, you can do these double quotes. That just means you're copying it down. And we know this because of the definition of linear pairs. All right, well, because we know both of them are linear pairs and everything, we also know, and I'll change it, I'll alternate colors here, that angle 1 plus 2, because they're linear pairs, are going to add up to be 180. We also know that's the case for angle 2 and the measure of angle 3. They're both going to equal 180 degrees. And that's the definition, of of supplementary angles. All right, well, because we know that's the case, we can set it up equal to each other because notice in the middle, they have the same thing. So we are going to use the transitive property here to write that measure of angle 1 plus the measure of angle 2 is going to equal also the same thing as the measure of angle 2 plus the measure of angle 3, because they both add up to be 180, so we can set them equal to each other. All right, well, now we're going to, hey, did you notice this? They both have that measure of angle 2. Well, let's get rid of it. If we subtract it from both sides, we're going to get the measure of angle 1 is equal to the measure of angle 3. Well, hey, we just subtracted. That's our subtraction property. Now, just because it says the measure is equal does not mean it's congruent. We have to state that angles with the same measure are congruent. All right, so you guys are going to be practicing a little bit more, and you're going to learn more of the postulates and the axioms that we're going to be using for angles and segments. Good luck.